Hello everyone. So if you're learning LangChain, you have a question, right? So you notice something confusing. Why are there so many different language packages? We have seen LangChain Core, LangChain, integration packages, community packages, and then you will hear about LangGraph, LangServer, and LangSmith, right? So are these all different backend frameworks? Do you need to install everything? And more importantly, how do all these pieces actually fit together? In this video, we'll break down the LangChain ecosystem from the group put up, understand what each package does, and see how they work together to build a real generative AI applications. By the end, the LangChain ecosystem will make a lot of more sense. So, hello everyone, I'm Punyakeerthi BL. This is part of LangChain tutorial from Python to Generative AI by Punyakeerthi BL. So, you will learn LangChain, LangSmith, LangServe with LLM models and build your OpenAI Gen API in this video series. Let's start with introduction. When beginners start learning LangChain, one question comes up almost immediately. Why are there so many LangChain packages? You may have seen package names such as LangChain, LangChain Core, LangChain OpenAI, LangChain Community, LangGraph, LangSmith. At first, this can feel confusing. Many people assume LangChain is just a single Python library, but it is actually an ecosystem made up of multiple packages. Think of it like building a house. A house needs a strong foundation, walls, doors, electricity, plumbing, furniture. Each part has different responsibility. Similarly, LangChain separates different responsibility into different packages. This makes the framework easier to maintain, easier to extend, and easier to integrate with new AI services. In this lesson, we will explore the main packages that form the LangChain ecosystem. So, the LangChain ecosystem look like this. We have LangChain package which contains chain, LCAL, agents. Then we have LangChain core, prompts, models, parsers, messages. Then we have integration packages, community packages, and external services. So each package has a specific job. So one question is, why does LangChain have multiple packages? Imagine a software company that keeps everything inside one huge library. Over time, the library goes to include AI models, vector databases, cloud services, PDF readers, web loaders, databases, search engines. Eventually, the project becomes difficult to maintain because every update affects everything else. Instead, LangChain separates these features into smaller packages. This provides several advantages. One is easier to maintenance. Each package can be updated independently. For example, OpenAI releases a new API. So only the OpenAI integration package needs to be updated. The rest of the LangChain remains unchanged. Next, smaller installations. You only install what your application needs. For example, a chatbot using OpenAI does not need packages for Google Gemini or Anthropic. Instead of installing everything like huge package, you install only the required components like LangChain, LangChain Core, LangChain OpenAI. This reduces unnecessary dependencies. Then third advantage is faster development. So different teams can work to different packages simultaneously. For example, LangChain team improves core, OpenAI team improves OpenAI integration, community members contribute loaders and utility. Then development becomes much faster. So till now we understood the LangChain advantages. Let's understand packages. First package we need to understand is LangChain Core. What is LangChain Core? LangChain Core is the foundation of entire ecosystem of LangChain. Everything else builds on top of it. Think of it as an engine inside a car. Without the engine, the rest of the car cannot function. So what does LangChain Core contain? It provides the basic building blocks required to create AI application. Some examples include prompt templates, chat messages, output parsers, language model interfaces, runnable components, callback interfaces, core abstractions. Notice that LangChain Core focuses on interfaces and reusable building blocks, not on specific AI providers. Then real life analogy, imagine you are constructing a building. Before adding walls and furniture, you first create a foundation, columns and beams. LangChain Core serves a similar role. It provides the structural components that everything else relies on. So installing LangChain look like this. Install pip install LangChain Core. Once it is installed, you can create the prompt template using code like this. So we first import a chart template, okay, chart prompt template class from LangChain Core prompts. This class helps us to create reusable prompts with placeholders. The template contains is variable called topic. When we call invoke, we provide a value for that. variable. In this case, we are passing machine learning. LangChain automatically replaces the placeholder with the provided value and prepares a structured prompt that can later be sent to a language model. This approach avoids hard coding prompts and makes your application easier to maintain. Next example is prompt reusability. Here we have topics, and for each topic we are passing prompt.invoke the topic. Okay, so by this, why this useful? Instead of writing for separate prompts, we create one reusable template and supply different values. This reduces duplication and keeps prompt consistent. So where will you use LangChain Core? Almost every LangChain applications uses it. For example, chatbots, RAG applications, AI agents, document processing, summarization system, question answering applications. Next, we have package 2, LangChain. LangChain is the package 2 which we are going to explore now. Once we have the basic building blocks, we need way to connect them together. This is where the main LangChain package comes in. It provides tools for building complete AI workflows. So what does LangChain provide? The package helps combine different components into a sequence of steps. Typical capabilities include chains, LCL like LangChain expression language, agents, basic support, retrieval workflows, runnable pipelines. Instead of thinking about one prompt, think about the entire flow of an AI application. For example, here the flow. User asks the question, then it will use to prompt template sent to the language model, then output processor will pass the output produced by the language model, then we will get the final response. The LangChain package helps to connect these pieces together. Let's understand example workflow. Here it is like first we import the chat prompt template to create a user prompt template, then import chat OpenAI to interact with the OpenAI chat model. Once it is done, create a prompt template and topic. Here topic is the placeholder that will replace with actual input at runtime. So once it is done, we are creating an instance of chat OpenAI model, and by default it uses the API key from the OpenAI API key environment variable. So then next step, create a LangChain expression language chain. The pipe operator connects components together. The flow looks like this. First user input, then input will be transferred to prompt template, then prompt template sent to OpenAI model, then you will get the response. How to run the next step is executing the chain. The dictionary provides the values for variables in the prompt template. Here topic becomes the vector databases. The model returns a AI message object, then content extracts only the generated text from the response. So by understanding step-by-step action, generally what we are going to, so first we are creating the reusable prompt template, initialize an OpenAI chat model, then connect the prompt to the model using pipe operator according to LCL syntax. Then we provide the input data, receive the generated response. This demonstrates how LangChain allows us to build workflows by composing reusable components. So why chains matter? Instead of manual writing code like this, prompt and send a request, receive response, process output, return result, then LangChain lets you connect these steps into a clean and readable way. Next package we are going to explore is integration packages. LangChain itself does not include every external AI service. Instead, separate integration package connect LangChain to specific providers and tools. These packages act as adapters between LangChain and external services. Examples of integration packages: LangChain OpenAI connect to OpenAI models, LangChain Google GenAI connect to Google Gemini models, LangChain Anthropic connect to Anthropic Cloud models, LangChain Pinecone connect to Pinecone vector databases, LangChain Postgres connect to PostgreSQL databases, LangChain AWS work with AWS services. Each package focus on a particular provider or technology. Then why separate integration packages? Imagine OpenAI releases a new feature. Only the OpenAI integration package needs to change. Other packages remain unaffected. The modular design keeps the ecosystem flexible and easier to maintain. Let's understand installing an integration package. So we are installing pip install LangChain OpenAI. So here by code we can see here the LangChain OpenAI model package provides the classes needed to communicate with the OpenAI models, and LangChain handles the integration through a consistent interface. Now we understand integration packages, right? Let's go with the next package for LangChain Community. Not every useful integration is developed by the official LangChain team. Many contributors from open source community create additional integrations. These are grouped under the LangChain Community package. So what does it include? Common examples include PDF loaders, CSV loaders, text file loaders, web page loaders, YouTube loaders, GitHub loaders, community supported model integrations, various utility tools. These components to help developers work with different data sources and services. Let's understand installing the community package. So pip install LangChain community. Once it is installed, we are able to see here this code will import the text loader. That text loader loads that .txt file, so which can be used for next services. The text loader reads the contents of the text file and converts into format that LangChain can process. Similar loaders are available for PDFs, web pages, CSV files, and many other documents. So for example, loading a PDF, here also we have PyPDF loader. This loader extracts text from the PDF, so it can be used for tasks such as summarization, question answering, or building a RAG application. So real world example, suppose you want to build an AI assistant that answers questions about company documents. You could use the following packages together. First one is LangChain Core, which will help us to create a prompt templates and manage reusable components. Next one is LangChain Community to load PDF files from your knowledge base. Then LangChain OpenAI to connect to an OpenAI language model. Next is LangChain to combine everything into a workflow that retrieves information and generate answers. Each package contributes a specific capability, making the application modular and easier to maintain. So, common mistakes beginners make: installing only LangChain and expecting all integration to be included. Most providers require separate integration packages. Next one is confusing LangChain Core with LangChain. Core provides foundational abstractions, while LangChain focus on building workflow and orchestration. Using community loaders without installing LangChain Community, these integrations are distributed separately. Hard coding prompts instead of using reusable prompt templates from LangChain Core. So best practices: install only the integration packages your project actually needs. So use prompt template instead of writing raw prompts throughout your code. Keep workflow modular by separating prompts, models, and document loaders. Prefer official integration packages for major providers when available. Stay updated as LangChain evolves quickly and new packages are released regularly. I have a set of interview questions, so that will be shared in the link in the description of the YouTube video. Please go through and read that one. So one of the question is, what is LangChain Community used for? It contains community maintained integrations including document loaders, connectors, and additional tools contributed by the open source community. Like this, we have almost 3-4 questions are there. Please go through our description. You will get the link to read these questions and the answers as well. So key takeaways from this video is LangChain is modular ecosystem, not a single monolithic library. We learned this. The LangChain core provides the foundational building blocks. This also we learned. LangChain helps compose these building blocks into AI workflows. Then integration packages connect LangChain with external models, databases, cloud services. Then we have a LangChain community offers a wide range of community contributed integrations and utilities. Let's recap and close this video. In this lesson, you learned why LangChain is organized into multiple packages and how each one serves distinct purpose. You explored LangChain Core as foundation and the main LangChain package for creating workflows, integration packages for connecting external AI services, and LangChain community for additional tools and document loaders. With this understanding, you now have a clear picture of core components that make up the LangChain ecosystem. Are ready to explore advanced packages such as LangPro, LangGraph, LangServe, and LangSmith in the next lesson. Thank you for watching. I am Punyakeerthi and this is the video from LangChain tutorial from Python to GenAI, which is created by Punyakeerthi. So you can learn LangChain, LangSmith, LangServe with LLM models and build your own GenAI using this series. If you feel this video is helpful, please subscribe and share it with your friends. Thank you very much.